So in this video we're going to be doing some of the analysis, and with all our images that we captured on the Raspberry Pi during the data collection phase, we've now imported all of those images onto our laptop here, and so we can start beginning the analysis. So the first step is, of course, to go to PyCharm and run the color picker. And so I chose the picture we found at 340 degrees, and let's run the color picker on this to see what HSV values we should use. Awesome. So now we can start messing around with the HSV values until we can get this line laser that we see here isolated nicely in our brush over here. So we kind of just move this around until we see something we kind of like. So maybe there, and then maybe something like there, and then maybe. So that looks pretty good to me. So these are the values we'll use in our data generation code. So I've already plugged in those values over here. And let's just run this code while I kind of talk about it in the background, because it does take some time to run. So important things that we wanted to address in this code while we're setting it up was we wanted to make sure that we carried over our RO and RPC values from the previous homework where we actually calibrated the line laser. And these values are really important so that we can actually make sure that we're using the right distances that we find. Same thing with the height, that's important. And what we're doing in this code is really just going through all the images we captured on the Raspberry Pi and kind of pulling XYZ points from them and storing them into a text file here. So as you can see here, we're going through it image by image, and it's kind of a lengthy process because we took a good amount of images. So luckily for us, I already ran the code and I have the text file. So the next step would be to then go to the MATLAB. So this is the MATLAB code that we were looking at. And it was important to make sure that we were importing data from the right area. So I had called mine the line images target, and here are the test results within that. And this code also took a little bit of time, so I already ran it for us. And this is where we see the following graphs. So at first glance, it kind of doesn't really look like a grill, but if you look at it at certain angles, you can see that here, this is where we have that column of the grill. And if you look a little bit closer, this is kind of where the actual grill is there, because you can see it's nice and straight lines. But then if you look a little bit closer, you see all of this kind of noise that spreads back here. And I was a little confused as to why this showed up, because all the images look pretty good. We're able to isolate the laser really well. And as I started to look at some of the later pictures, as we moved up our angle, it became a little bit more clear to me that, the grill is right outside of the Commons apartments, and college students, they love to stay up late. So it was actually, as I looked closer, it turns out that all the windows and apartments right behind the grill, all the lights were on in all the rooms. So I was getting a lot of additional background noise that I honestly didn't anticipate. And it's definitely something that I want to make sure I'm cognizant of going forward. And so maybe I'll shoot my videos and take my data at more obscure times where I think, more students would be sleeping and lights would be off. So I can just focus on the grill and have a lot less noise in the background. So overall, that's the analysis we have here today. And I'll see you guys next time.